Good morning to everyone. Today I would like to discuss very important topic in the 10th class, that is called as atomic structure. What is meaning of atom? If you take any one matter, the matter is any matter in this universe is made up of so many number of very small minute particles, the small minute particles, that is called as atom. Means atoms are combined together, we get the matter. We get the what? Matter. So we are going to learn about the matter, means you should be learn about the what? Structure of atom. If you learn the structure of atom only, then only we can possible to understand what is meaning of matter, what is the properties of the matter, and what is the physical and chemical, and how the matter can be behave. Everything we can discuss by learning up what is the structure of this atom. To explain the structure of atoms, we have so many atomic models are there. In that, first atomic model is our Rutherford. First atomic model is the J.J. Thomson atomic model. After the J.J. Thomson atomic model, we are going to discuss about the Ernest Rutherford model. After the Rutherford model, we have Bohr's atomic model. We have Bohr's atomic model. Bohr's atomic model. So if you learn these three atomic models, we can easily know how the atom is made up of. So today I want to focus on this area that is called as Rutherford atomic model. So let's go the Rutherford atomic model. This is also called as Rutherford nuclear model of an atom. Why I can call it as a Rutherford nuclear model of an atom? Because after the Rutherford experiment, we came to know that there is a atom, there is a center, there is a one positive charge particles are there, that we are calling as a nucleus. Let me go how Rutherford atomic model can be explained. So Rutherford and his students, they done one experiment. That experiment we are calling as a Rutherford alpha ray scattering experiment. Why I can call it as a Rutherford alpha ray scattering experiment? Because let us look at the experimental setup. In this experimental setup, this I can call as a gold file. This I can call as a gold file. This gold file having very thin, this nearly 100 nanometer size. 100 nanometer size. And they're taking the source of alpha particles. The source of alpha particles means from this source there is a generation of the alpha particles. There is a generation of alpha particles. Generation of alpha particles. That alpha particles are passed through this lead plate slide, and they go and struck the thin very gold file. When it is struck the thin gold file, most of the alpha rays, look at here, see this, most of the alpha rays are struck the lead sulfide plate. This we are calling as a zinc sulfide plate, not lead sulfide plate. It is a zinc sulfide plate. It is a fluorescent material. What is meaning of fluorescent material? Fluorescent material, it is a fluorescent material. What is meaning of fluorescent material? Means if any light is struck on this lead zinc sulfide plate, automatically here we are seeing some flash here. Here we can see the flash. Okay, that we are calling as fluorescent material. Means most of the alpha particles what we passed here, that alpha particles are strike the zinc sulfide plate without any deflection. Most of the alpha particles are strike the zinc sulfide plate without any deflection, without any angle of deflection. But few alpha particles are striked with some deflection. Few alpha particles are striked with some angle of deflection. And one of very few alpha particles are bounced back. Okay, this I can clearly show in the next slide. Let me look at this slide. When you pass the alpha particle from this source through this lead plate, and this is a photographic plate we arranged here, Okay, no, and there is a middle exactly, we keep it at gold plate. And when you pass some alpha particles are here, thus alpha particles are this, most of the alpha particles go on strike without any deflection, but few alpha particles are what strike with what small angle, and few alpha particles are some few very few alpha particles are bounced back. This is how the experimental setup. Now the very important thing is, if you go inside the gold particles, what happened? Look at here, when alpha particles are passed here, look at here, most of the alpha particles are passed without any deflection. See, look at here, pass without any deflection, but one of the alpha particles are bounced back, and some of the alpha particles are scattered with some angle. These are scattered with some angle, but these alpha particles are without any deflection, it is coming. Without any deflection, it is strike the lead sulfide place, but one of the alpha particle, what the alpha particle is there, these alpha particles are bounced back. Okay, now based on this is the observations we are observed in this experiment. Most of the alpha particles are passed through gold foil without any deflected, and a small fraction of the alpha particles are deflected by small angle, and very few alpha particles, nearly 1 among the 20,000 or 1 among the 1 lakh, retracted their path, is nothing but bounced back.